Hello there everybody, Sam's Trains here, welcome back to the railway. Today I'm going to be investigating some faulty steam locomotives. I want to say a huge thank you to you all because a couple of months ago I posted a video of me investigating and fixing a couple of faulty locos, not knowing whether anybody would even watch or enjoy the video, and it turns out that loads of people did watch it, and I got tons of comments from people saying how much they enjoyed it and how they'd like to see more like it, and so today I'm going to be doing exactly that. I've got a couple of steam locomotives, both of them I suspect are faulty, and I'm going to be investigating them today to see if I can fix them. Now, the first locomotive has plagued me for years, and this is why I'm being very careful to use the term investigate rather than fix, because I'm not entirely sure that I'm going to be able to fix these. I've got a few ideas on how I can improve these to try and sort of get rid of some of the issues, but whether or not these are actually fixable, I'm not entirely sure. So the first locomotive, you guessed it, it is this. It is the Oxford Adams radial tank. And these are known for quite a few design issues. One of the major ones is the springing of the front bogie and the lack of springing of the rear pony, which actually prevented these from taking inclines without just wheel slipping. Well, that's not the issue I'm investigating today. I fixed that issue on mine, so that's not even the problem. The issue with this particular one, as you can see here, this is at 50% speed, is that they're just running far too slowly. Now, every time I've said this in the past, people have said, that's fine, these locomotives are designed to run slowly. Now, that's fine, but 4 or 5 years ago when I got this locomotive for my birthday, it didn't run like that. It was much faster. If a locomotive is designed to run slowly, it will always run slowly. It won't degrade over time. No, this one slowed down over the first year or so of me owning it, and the really weird characteristic with this one is that it continues to slow down as it warms up. Usually you expect better performance after half an hour's running. These slow down to a crawl. In fact, my Southern Green version of this did that very clearly in one of the reviews I filmed. So that suggests to me some sort of heat is going on here. Maybe the motor is heating up, maybe something's expanding and creating massive friction. Is there something on the circuit board that's heating up and causing resistance? I don't know, there's quite a few things I want to try with this. Let's get it onto the workbench, let's do some tests, let's investigate and see if I can bring about any improvement. Quite excited about this. It's a loco that's plagued me for years. Maybe today I'm going to crack it, maybe I'm not, maybe I'll still be scratching my head. Let's find out. So I do have 1 or 2 ideas for this one. Folks have gotten in touch and left me suggestions in the comments, and I've got 1 or 2 ideas of my own as well. The first thing I'm going to do is I'm going to start by just testing how much power this loco draws when it's running, because if a loco draws way too much power, that can be an indication of a faulty motor. So I'll hook up the ammeter and I'll connect it up to my locomotive. And I'm expecting between 1 and 200 milliamps. If it's much more than sort of 200 milliamps, I'm going to start suspecting it. So let's turn it up to 50% speed and see. We'll hold it on there just for a second. Now already that's at 50%. That is running quite a lot faster than it was when it was down on the track. So we've got about 134 milliamps there. What if I introduce some resistance? It does slow down and it does draw a little bit more current, but never more, well, no, not much more by the looks of it, than 200 milliamps, unless I really push hard. And if it stalls, it goes over 200. Okay, interesting. The other thing that I was thinking, well, the other thing that's been suggested to me, and the other thing that I know to have some credence to it, is the DCC socket and the circuitry on board that socket. I've actually known some of the components on those circuit boards to cause trouble. I think it was my county class, my Hornby Railroad county class. That thing slowed right down to a crawl, smoke came out, it wouldn't work again afterwards. I think it was shorting. I thought the motor's gone, it's popped. Turns out it was the suppression capacitor across the motor. It had failed, it had gone short, and then it was just drawing all of the power basically and stopping the motor getting any. So I would never rule out sort of circuitry components. It's very annoying if that's the case because you need them, particularly those caps to protect the motor. So if they go bust, yeah, it's pretty annoying, but we shall see, we shall see. So I'm going to remove the body, and then what I'm thinking of doing is disconnecting the motor. I'd don't really know if I really want to go this far, but I'm thinking I might. Disconnect the motor from the decoder circuitry and then power the motor directly and see if there's any difference in the speed and see if there's any difference in the current draw. So I'm actually genuinely thinking I might do that because this looks fairly easy. We've got a couple of motor contacts right here on the circuit board. I could desolder those. There's actually nothing in parallel with the motor at all. So I'm thinking we'll do that straight away before I investigate the rest of the loco. And then it's kind of more scientific that way, isn't it? So let us zoom in and let's get to soldering, or rather desoldering. So the black wire is furthest from me when the loco is this orientation. That's fine. It's just so that I don't wire the thing up backwards, because that's really annoying when I do that. And it happens a bit too often. So I need to at least make an attempt to avoid that. Right, so I'm going to just tin up my iron. The soldering from China is usually rubbish these days because they use solder without any lead in it. So not expecting this to be too difficult, and indeed it was not. Cool, so that is now disconnecting the decoder socket. See these components on the decoder and around the decoder? Those are all entirely disconnected now. We literally have direct access to the motor. So I just need to secure the locomotive. I'll hook up these wires again and we'll test it again. All right, I'm hoping this camera will be able to see that. Apologies if you can't see the screen very well, but I shall read out the result. Okay, try again. You know, I'm not really seeing a big difference. What happens if I put pressure on it again? I think we can call that busted. It's behaving in almost exactly the same way, to the point where I don't believe that is the problem. So I will reconnect this and then I will show you my next plan of action. Okay, I think we are soldered back together. Let's just check we've actually got power. Yep, we do indeed. Okay, nice. Okay, so the next thing that's suggested quite a lot is to wash the motor out with cleaning fluid of choice. In other words, to clean the commutator without actually cleaning it. I've heard this suggested quite a lot. I have tried it, didn't work for me. Not saying it doesn't work for other folks, but I have tried that with this locomotive and that did not work. So the next port of call for me is going to be to investigate the gear train. I've heard that Oxford Rail use a lot of lubricant, and the story goes that this lubricant goes sticky and viscous and stops the mechanism working properly. That to me sounds feasible at this point, now that we've ironed out now that we've ruled out any issues with the actual motor and the circuitry. And there is a certain way of getting access to the gear train with this. In fact, there's a secret door. Sounds like I'm making this up. I'm not. There's literally a secret door inside this mechanism, which allows you to access the actual gear train so that you can clean it up. Again, I've seen people suggesting you flush this through with cleaning fluid. It doesn't really do the job though, does it? It doesn't remove the matter. It just sort of dissolves it and maybe waters it down, but it's still in there. So I'm going to go for a full disassembly here. You can see what I mean already. There's lubricant visible on some of the various parts. So I'm going to try and clean these up. Now, can I get the worm drive out? I'm going serious. I'm actually going to take all the different parts out. The worm drive is held in with just a drive shaft, a mini one. So I'm thinking I'll be able to get this out. Yep. It's going to be a bit of a devil to get that back again. But for now, it's out. Okay, put that safe to one side. And to get the secret door, oh, this sounds so awesome and mysterious. It's not that awesome, but it is pretty mysterious. We have to remove the base keeper plate, and I think some of the wheels as well. Yeah, it's pretty hardcore, it's very hardcore, but you know what? I want to fix this if I can. If there's a chance of fixing it, I want to take that chance. Base keeper plate is almost off. Something's holding it in. Ah, there we go, got it. And there's a little detailing piece here, which you will want to just pop off, I believe, because that gets in the way when you're trying to put the piece back on. So take that off, remind me to put that back on, if you have the power to go back in time. Right, so the thing with this is to be very, very careful not to disturb the cylinder assembly and the crossheads, because if they come out, you've got to thread them back in again. So I'm just going to lift those wheels out very gently. And the door that I speak of is on this side here. So I'm actually going to do a dangerous thing and lie this down. Bad idea. But there is the secret door. It doesn't look like a secret door, but it's literally not held in at all. You can just pop it right off, as I understand it. And I have actually done this. I did this with my green Adams Radial tank, and it did bring about a slight improvement, so I'm sort of confident. Okay, it's off. There we go. And let's have a look at some of this lubrication. First things first, there is what looks like a bit of metal shaving. You're not going to see this on the camera, but it looks like a bit of copper that's shaved off. That was in one of the bearings, so that won't help. And the lubricant, it's very sticky and viscous. So that piece is going to need cleaning up. And I can see actually that there is some lubricant here that looks like it's hardened. There's a bit of it on my screwdriver. That feels pretty solid. So I think this could be one of the problems. It's not a nice one to fix, but yeah, can you see that? We've got like little solid bits of lubricant. That won't be doing the mechanism any good. So basically it's going to be taking a lot of energy to turn these gears, and rather than lubricating them, whatever Oxford have put onto these gears has solidified somewhat to become more viscous, and it's actually adding to the problem. It's actually taking energy rather than requiring less to turn these gears. So I bet we're onto something there. So I'm going to clean these up and we will see what sort of difference this makes. Okay, so that has taken a little while, but I'm now confident that none of these mechanical components have any lubricant on them whatsoever, which means we're starting with a clean slate. Incidentally, the motor seems very free, very, very free to turn without anything connected, to the point where I don't really think it's the motor to blame. I suppose I could lubricate this end of it, but I'm very, very cautious about lubricating the brush end because there's no way to access the brushes without fully dismantling the motor, which is not pleasant with these. So I'm not going to do it. But there we go, I've lubricated the end I dare to lubricate. Right, so now we've got the immense fun of reassembling this beauty. So let's do it, I suppose. I can still see a little bit of IPA inside the mech. I want to get rid of that because you don't want to apply lubricant to a surface that has IPA on it, because the IPA will obviously react with and chemically change your lubricant. Great. Awesome. Everything is dry. Right, so the gears go back like so. In fact, there are lots of locos that have this sort of mechanism, and the gears go back in exactly the same way with all of them, which is quite good. I'm going to lubricate the shafts that the gears sit on with standard oil. Plenty on there because it's never going to see the motor that way, so that's fine. Right, let's put each one on, make sure each is very free to turn. Yeah, it is. It's not the loveliest design in the world. These are just literally shafts that are moulded or casted into the chassis, so there's not going to be no resistance there, but there is very, very little. It's very good. Okay, let's see. What do I do next? Yeah, let's lubricate it. Let's put some of this is just Sealy silicone grease. I'm very careful about recommending things like this because I really don't know how they're going to react. But I've been using this now for quite a long time, and I did that on purpose before I started sort of talking about what I use, because if it damages things and doesn't work properly, you know, people will buy it and use it, and it won't do them their locos any good. Okay. So that was really interesting. When I first put that on, the gears stiffened up hugely, and now that I've turned them around and worked it in a little bit, they've loosened up hugely, which is good. So there we go, not too much of that. I don't want it gummed up like it was before. Then I can put the trap door back on. I know I shouldn't be calling it a trap door, but that's just the coolest name for it. There we go, I think that's it. Okay. Now let's get the wheel set back in. Ooh, I can see some more lubricant on the chassis. There, that's taken care of that. Let's pop this back on. Right, so that is free as a bird. Look at that. so easy to turn those now. To the point where if it doesn't improve now, it will have to be the original diagnosis, and that is that the motor is just underpowered. I can't really think of what else it could be if this doesn't fix it. So base keeper plate going back on. This is the annoying part because the pickups have to reach right down to the underside of the wheel. More lubricant, keep finding it. I'm going to get rid of that before I put it on. So I'm just going to creep up to the tightness on these. So they're just very lightly finger tight. That's still free to turn. Let's tighten them up then. All right, okay, that's not a problem anymore. That's very free. It gets a little bit less free because you've got pickups now pushing on each wheel. But yeah, that's not a problem. That's standard. That's about how most locos feel. Let's replace the worm drive then. A little bit of a difficult thing to do this. So this threads in like this. It's real art to this. Really dodgy to get the angle right. Okay, so that is all done and back together. Let's do one more test then and just figure out whether or not this is still working, and we'll do a current test as well just to figure out whether it's drawing any less now. We will see. Although I don't remember exactly what it was drawing before, so. Okay, 0.12. It's accelerating. 0.13, 0.12, it's dropping. As it's running, it's dropping. It's getting faster. I don't know, are we seeing some sort of self-repair going on here? It seems to be getting better and better. Look at that, we're dropping almost down towards the 100 milliamps mark. That is definitely less than it was before. Well, interesting. Faster? That is looking quite healthy. That's looking very healthy, but the thing is, it always kind of does. It always looks healthy on the bench. It's when you start putting the body on and you get the extra weight on the chassis, it starts to get a little bit more resistive somehow. So I suppose I need to do that test again when the body's on, because then we can rule out the body pushing on the flywheel or something, I don't know, and causing more resistance there. So that's worth testing, I suppose. Don't forget the detail piece at the back. There we go. Right, okay. So the body is back on. I've tightened up the screws to my taste, which is fairly tight. So now if it still works okay, we know that the presence of the body is not producing any more friction. Of course, there will be more friction when we get it on the track because the body's heavy. There's lots of metal on it, so it's going to be pushing the loco down onto the track a bit. I don't know if you can see the ammeter here, but it's the same current more or less. In fact, it's getting, what was it, 106 before? It's now at 107, so that difference is negligible. Oh, 104, 103. All right, so the friction's very, very low. So it's the moment of truth time, folks. Let's get this onto the track and let's give it a test, maybe on its own to start with, maybe then with some coaches. We shall see. I'm excited. Okay, the moment of truth. Now remember, this is how the loco was performing before I did anything to it, so this was it just snailing along at 50% speed. Is it going to be any better now? I'm really not convinced. I didn't find anything seriously wrong with it, unless removing and replacing that lubricant has made a big difference. I can't see the difference being huge, but hopefully some improvement would be nice to see. So here we go, 50% speed. Well, I don't know. That does actually seem a little bit better. That's nowhere near as bad as it has run in the past. Let's have a look. Let's put my fingers in front of it. Well, it's got some torque there, hasn't it? I don't know. I mean, this was never a fast loco, but I think that's better. You'll have to watch my Adam's Radial tank videos and compare, but I think this is actually a lot better. And its top speed is a lot better as well. Wow, I'm surprised. That's actually really not bad. I'm sure I've never seen it since, you know, the first time I got it 4 or 5 years ago. I'm pretty sure I've never seen it run as freely as this. Look at this. You can cut it off and it doesn't stop dead. I don't know, there's something a lot freer about this now. Something. All right. I'm really pleased with that. That's not bad at all. But we are not done. There's still another loco to look at. The second loco of today is another engine that has had me scratching my head, this time right from the start though. This one didn't degrade like the Adams radial tank did. This one ran pretty badly from the start, although actually, to be fair, the last time I ran it, it was much worse. So the loco is this. It is the latest Hornby large Prairie, and the fault characteristics with this are quite similar to the Adams radial tank. It's very slow and underpowered, to the point where if I run it on my second radius curves, the thing slows down to an almost stop. This was at 50% speed. That is not normal. And it doesn't change as the loco runs in. It doesn't get better, it doesn't get worse as it runs in. It is just like that. And there's also an almost complete lack of torque. You can see me putting my fingers before and behind the locomotive here. The wheel set almost entirely stops. Now that's not normal for a large Prairie. These are fairly powerful locomotives. I've had comments from other owners of this model. Some of them say theirs behave like that. Others say they do not. So I'm convinced that this is a known fault with these. I'm not 100% sure, but that's what I believe. So what could it be? I suspect it's the motor. I do suspect the motor. If it's the motor, that is quite an easy fix. So that's the good news. The bad news is I don't have a replacement motor. So yeah, be it that as it may. The other possibility is that there's some major source of friction in the mechanism here. The good news with that is that I probably won't need any extra parts to fix it. I can probably just do that with my hands and my tools. The bad news is it's a bit more complicated, a bit more fiddly, a bit more tricky to diagnose. So let's do some similar tests on this. I'm actually fascinated to see what happens with this one. Again, don't know if it's going to be fixable, but let's try. Okay, let's give this a try. I'm excited about this one. I've not opened this one up since I did it for the review, so this really will be quite interesting. Never had too much confidence in the design of this one. It seems silly, but I think it's because of the front pony design, because they've done a bit of a KR models, if I remember. If I tighten it all the way up, the bogie becomes rigid. Hang on, let me show you this. If I literally tighten it right the way up, the bogie cannot move. Look at that. So again, it's what KR models should have done. This screw here should have a collar on it. This is a total tangent, isn't it? But there is no collar. You can tighten it all the way up. And also, well, I guess the collar's on the chassis, look. The collar is on the chassis, but it's not long enough. And so when you tighten up the screw all the way, the screw does apply a force onto the pony assembly, and therefore you have to, again, like the KR GT3, you have to leave the screw sort of semi-loose, otherwise the thing can't turn properly. So it's that little thing that caused me to lose my confidence in the design of this loco, because besides that, the mechanism looked absolutely fine. So what am I going to do? Well, it's going to be really similar, actually. Hopefully this won't be too boring. I want to test the motor, because again, I have a real suspicion that it might be the motor. We will look at the lubricant. This is a newer loco, so has the loco had years and such for the lubricant to go hard? No, not really, but it's possible, I suppose, isn't it? I don't know. We're going to have to just open this up and we'll see where it takes me when I see the insides. And let's have a look. It's not so easy to just run this with the controller, because none of the non-driven wheels have pickups on them. Do you know what? That's interesting. Two locos showing largely the same symptoms. Does that motor look like the same motor to you? The mechanism looks like it's an almost identical design. That's weird. Is it just the motors then? Are these not good motors? I don't know. It's either a crazy coincidence or it's not a coincidence. I don't know. I guess I could connect directly up to the circuit board. Let's try that. Okay. Speed looks absolutely fine there. Wouldn't complain about that at all. Not a great deal of torque though, is there? And actually it's much worse when it's on the track. Go on then, let's do the ammeter test, because this will just reveal whether there's any major issues. Go. It seems a lot faster this way up. Rather high, 1.85. How can I put pressure on and hold that contact at the same time? I saw over 2. It was hard to get the Adams radial to go up over 200. 200, is that 50? I can't really read this upside down. 2.6. So yeah. So under load it's drawing quite a lot of current, quite a lot more than the Adams radial did. It's just thrown me that this appears to have the exact same mechanism inside it. I mean, I open up all of my locos. I don't think this one has had its service yet. But I didn't, obviously the last time I opened this mechanism up, I didn't realise that there was going to be any issue with the performance. Now that I've seen the way it runs and I've seen how underpowered it is, and the fact that that matches exactly with the Adams radial tank, almost exactly, which is also really underpowered, it's just, it can't be a coincidence, can it? My gut instinct was always with the Oxford Adams, was always the motor. I always thought, yeah, it's the motors, they're underpowered. Other things wrong as well, yeah, the springing in the front bogie, etc. These are issues too, but I'm still convinced that the motors play a part. Because really, if it's a really good, powerful motor, like the one in that Merchant Navy I reviewed, is a bit of lubricant really going to make or break the locomotive? I don't know. It feels like a good motor that's able to haul a massive long train, for example. Is it really going to be held back by a few drops of lubricant that have gone sticky to a point where it's going to completely bottle the performance? I'm not convinced. So now what needs to happen is the decoder socket needs to come off so that I can loosen off that trapdoor. We can have a look inside. I'm going to do it. I'm going to clean off the lubricant because why not? And we'll see what happens when I do that. Okay, so I just need to get this cap off. There we are. Okay. Well, there's clearly a lot of lubricant in there. Probably more than I'd want to use. How does it feel? Yeah, it's not dead sticky actually, like the Oxford stuff was. It's going to be awkward, I think, to get the worm drive out of there without taking out the motor too. It's not going to hurt too much to pull the motor out entirely. I sound like a dentist. I'm worried about hurting my patient. I didn't mean it that way, but that's what it sounded like. Come on then, let's take the motor out. If we're doing the job, we might as well do it properly. So the motor is now free. Let's take the worm drive and the motor out at the same time. There we are. Oh, that's just, it's got like a hex end on it or whatever that fits into a hex cut hole into the flywheel, so that's fine. Yeah, that does look kind of messy actually, so I will clean that worm drive up at some point. Should we have a look how the motor behaves when it's not connected to the loco? Ready? Let's get it to crawl. So it's a bit iffy down at the low end. Turn it up a little bit. How's the torque? Yeah, it doesn't feel like there's a lot. But don't forget, we haven't got any step down in the gearing here. This is the raw motor output. And that's 50%. Yeah, to be honest, I mean, it's hard to tell. It has got a big flywheel on it. You can't test it without the flywheel or anything because the flywheel is part of the mechanical connection, so can't do that. Right, let's secure the motor temporarily and see if we can get those that trap door open. So there is a single screw there which needs to come out. Man, I've never gone into this locomotive at this level before. pretty cool. Okay, lift these wheels out. And then that trapdoor is wanting to come off already. I'm noticing there is an improvement in this design. That trapdoor is screwed on rather than just friction fitted, and that's good because the old one was dropping off on me again. All right, there's clearly some, ooh. That feels a lot more viscous. It looks like it started to solidify on there. Can you sort of see it there? Interesting. All right, so yeah, it's a really similar setup. Look at that though. Can you see that? There's like a ring of lubricant that looks like it's hard. It's not hard, obviously, but it's all gathered up. There's a lot of sticky lubricant anyway, should we put it that way? Well, why not? Why not? We've come this far. Let's clear them up, see if it makes any difference. Okay folks, I think I am there. Some of this stuff has still got to dry, but I'm now satisfied that it's all clear of lubricant. So we've got gears, different pieces. Yeah, it's all pretty much clear now. I've decided I think I'm going to just try using regular oil this time just to see what difference that makes. It's experimentation, isn't it? So I guess I will find out. So it's going to be pretty much the same drill as before. I'm going to oil the shafts, make sure there's as little resistance as possible there. The other thing I haven't really looked into so far is the issue of slowing down on curves and such. I think that will be due to the same problem that is causing the slow speed generally, but it could also be something to do with the gauge. I can't remember now whether I actually tested the gauge of this loco or not, but I think before I continue, I'm going to do that. So yeah, we'll stand by for a little bit of a gauge test. Okay, so just a bit of regular oil this time instead of the silicone grease. Generally, you do want to lubricate gears with something a little bit more viscous because otherwise it just washes straight off them. So that's beautifully free. That's very good. Right. I don't really know whether you need to or not, but I do tend to lubricate this piece. It doesn't hurt, I don't think. Just a little tiny bit of oil on those, just so that all the moving parts are greased. Goes on there. It's a good fit, I must say. There's something very satisfying about when parts fit together properly, isn't there? Right, put that screw back in, and then we can get this. I'm sorry about this. This is just, I know it's abhorrent to look at. We can get that situation fixed after this. All right, let's see. Let's clamp this in place. Let's get them in. Bearings realigned. Okay, I think they're in. Yeah, they're in now. Okay, does it turn? Yeah, it's fairly free. It's not as free as you might expect, given that there are no pickups. Okay, so let's go into servicing mode. Let me just clean up the axles as well and re-lubricate those. Right, now that is how it should have been. Look at that. So it turns out that, well, I didn't find any lubricant on these. On the centre axle, the one with the gear, it seems that there was that sticky, gloopy, silicone lubricant stuff all over the bearings, and those bearings were quite snug. They were quite difficult to shift. I've cleaned all that off and I've just put some regular oil on, and look at the difference there. Now that is better. That's how it should be. Let's check the gauging before I put the base keeper plate back on, but that's not the major. This is like a secondary issue. 14.4 though. 14.4, you can't see the readings, I'll read them out. 14.5, oops, a bit tight on that one. The gauging is not the problem. I might have actually tested that during the review, can't remember. But the gauging is definitely not the problem. Okay, base keeper plate is back on. Obviously it's now less free to turn because you've got 2, 4, 6 wipers wiping on the back of each wheel. But to say that that is the case, this isn't too bad. Yeah, this is still fairly free, but I'm glad we haven't got the extra friction from the axles this time. That's good. pull the motor out. I need to make sure that capacitor isn't touching the armature as well, but we can verify that. Okay, very fiddly, but it's in. Okay, make sure everything's free. That does feel remarkably free. There's very, very little friction in this system, and I haven't even lubricated the worm drive yet. Great. Well, I think if it's not the motor and it is some other source of friction causing the problems, then this loco will now work. I would stake my reputation on it. Do I think that's the case? I'm not sure. I'm not sure. Right, let's secure the motor and find out, I suppose. This is weird. There's like a cavity at the front of the engine here. That's where the smoke box would be. And there's like a little wire holder, what looks like a wire holder there. Did Hornby have plans to fit these with smoke generators? That's odd. Or perhaps that's just where the decoder's supposed to go. I see. My first thought was the most exciting, wasn't it? Second thought, much more realistic, much less exciting. Never mind. Curse you, lead-free Chinese soldering people. Ugh. Awful dry joints. Let's get this one soldered back on. There we are. It's not their fault, by the way. I think by law they can't use solder with lead in it. Well, it's working. All right. So let's reassemble, let's get it down onto the track, and let's see if it exhibits any difference. I don't think it will. I really do think it's those motors, but I could be wrong. Let's see. Right, the final moment of truth of today then. So again, I'm not feeling too confident. However, without the motor attached, I have been turning this mechanism with my bare hands, and I've basically verified that it is all completely free to turn. If this locomotive does not run properly now, then I feel fairly justified in blaming the motor or blaming something to do with the electrical connection or something, because mechanically I'm sort of 99.9% sure that this is fine. There's nothing catching, nothing is wrong. Let's have a look then. So 50% speed. Ooh. It's hard to say. Does that seem a little bit faster? That does seem a little bit faster. What happens if I put my fingers in front of it? Still not much torque there. Yeah, I do think whatever is the matter, I think the motors play a part, because I was never impressed with the Oxford Rail motors, and then discovering that this one has almost exactly the same looking motor in it, I don't believe that's a coincidence. Let's send this off around the layout though. Let's put some coaches behind it, see how it behaves on those curves. Remember then, this is how the loco used to run around those curves and that area with a set of coaches coupled to it. Not a pretty sight, not a good performance at all. Here it comes now then at 50% speed. It looks quite a lot faster already, but sure enough it is still slowing down on the curve, however not to the extent it was doing. So that's a definite improvement, isn't it? But it's still not what I would call acceptable. If this happened during a review, I would definitely be marking it down for its lack of power up that hill. So I am still going to lean towards calling the motor faulty, or at least prone to developing faults and then running badly. That might explain why some people have reported no issues when running these. Then again though, along the straight, as you can see, this loco does run absolutely fine. So maybe the people that have reported that, maybe they have level layouts, I don't know. Either way, the Adams radial tank is much happier now. It's got some coaches, as you can see, and it is handling them quite nicely. So yeah, while it's not definitive, and while I do still think the motors pose an issue, if you clear out that lubricant and add your own and make sure everything is turning freely, you can produce quite an improvement. And so I would say I've still learnt something reasonably valuable from this. And that is something that you can try as well if you're experiencing similar problems with these locos. So for now, thank you very, very much for watching. I hope you enjoyed that. At the very least, it's just, tinkering with locomotives, seeing how they work, opening them up, etc., etc. And so that part was pretty fun, wasn't it? And I hope you think so as well. Thank you for watching then, you take care, and I will see you very, very soon. Alright, cheers everybody.